Today we're going to look at simplifying algebraic fractions, and there's a couple ways you can do it. So you can simplify first or simplify later. As long as you end up with the right answer, I'm not really fussed. So let's look at this first one. Now, when you multiply fractions, hopefully we remember that you multiply straight across the top and bottom. So just an example, if I had something like this, you would just multiply straight across top and bottom. 2 times 1 is 2, 5 times 3 is 15. I can't simplify that fraction, so I'm done. So same thing here. But what you can do, if you remember from your basic fraction stuff, is cross multiply. So I can say that these are both 1. So then I'm just doing 1 times q is q, and y times 1 is y. Now you could simplify later, so you can do x times q is xq, y times x is yx, and then I could cancel out and still say it was q over y. I don't really mind which way you do it, as long as you end up with the simplified answer. Alright, same thing here. We can cancel both of these out and call them 1, so we just end up with d over c, or again you can say abd over cab and then cancel out the things that match. Now hopefully you remember your indice laws here, that all you do is subtract the powers. So if you have something like x cubed divided by x squared, you're just subtracting your powers, because what this is really saying is it's x times x times x over x times x, right? There's 3 on top and 2 on the bottom, so you cancel out all the matching ones and you're left with just x. So that's why we subtract our powers. Same thing here, there's 7 on top, 2 on the bottom, so we're left with 5. Now that's what I'm going to do here. I'm just going to subtract all my powers. So I'm going to say q, sorry, this is p and this is a 1. If there's no power, you can assume it's a 1. So 1 minus 2 is negative 1. So there are 2 ways you can do this. You can recognize straight away that a negative power means it's in the wrong place, so it should be on the bottom, or you can keep it as a negative and fix it later. 2 minus 3 is 1, so it's just q, and then 4 minus 1 again, that's what this is, so it's m3. If you give this as your answer, you are not finished. Now some of you were doing this at the very start of the year when I gave you that indices revision thing. So if this is your final answer, you are not done. You should end up with that, right? So the negative power belongs on the bottom. You could have gone straight to this step if you recognize that minus 1 belongs on the bottom. Either way, I don't care, as long as you ended up with this and you didn't stop there. Okay, over here, this time we've got numbers as well as letters. So I'm going to say what is the highest number that I can divide them both by. Well, I'm going to say it's 8. So if you said 4, you'd have to just redo it again. So what I'll do is say I couldn't tell it was 8 and I thought it was 4. Let's just do it like that. So 4 and then 3 minus 2, well that's negative 1 again. 1 minus 2 is negative 1 again. So then what I'm going to do is down the bottom, these are gone. 24 divided by 4 is 6. Now, you should be able to recognize that these two can be further simplified, which again would have happened if I just divided them both by 8 in the first place. And these 2 powers are negatives, so they should both be on the bottom. I'm going to halve both of these, so I'm left with 2 on the top, 3mn. So you could have just skipped straight from there to here. So you could have said that both of these divided by 8, so divide by 8, divide by 8. And then 2 minus 3 is negative 1, so then it should just go on the bottom, it's 1. 1 minus 2 is negative 1, which means it belongs on the bottom as a positive. So either way, I don't care what your reasoning is as long as you get there. Alright, same thing here. You can do some crossing out first, or you can just multiply straight across and then simplify. That's what I'll do for the sake of it, but you can cancel out first. So I'm just going to multiply straight across top and bottom. So 4 times 9 is 36. I have x cubed and y squared. And on the bottom, I have 3 times 2 is 6. And then I have x squared and y. Then I'm going to simplify. 36 divided 6 is just 6. So I'm left with no number on the bottom. And then I have, I shouldn't need a fraction at all, should I? Because these are all going to disappear. 3 minus 2 is 1, so I just have x. And 2 minus 1 is 1. So I'm just left with 6xy. Now if you wanted to pre-cancel, you could say that this is 1 and this is 3, this is 1 and this is 2, and then I could have got rid of this, and then I could have got rid of these, and then I just have 2 times 3 is 6, and then I'm left with an x and a y, and I'm left with nothing on the bottom except 1. Again, I don't mind which method you use. Okay, so now we've got 3 different things. Again, you can do some cancelling, or you can just multiply straight across the top and bottom and then simplify. So a squared, there's no other a terms, so I'm just going to leave it as a squared. B, there's no other b. C, D, E, and F squared. Again, put it all together. I'm going to start alphabetically. That's the way you should write it. So I'm going to go through my alphabet. So A, B, C squared, D, there's no E, then there's an F. Okay, cool. So now I'm going to do all my cancelling. So these disappear, these disappear. 1 minus 2 is -1, so that means this belongs on the bottom of my fraction. These cancelling, E stays on the top because there's nothing to cancel, and then 2 minus 1 is -1, so I end up with an F on the bottom. And that's what I should end up with. Again, you can just cross cancel over here if you want in any direction. You could have just immediately started doing this sort of stuff. Remember, the commutative law tells us it doesn't matter which order you multiply in. So that's why we can cancel in any direction from here to here. You know, you could do this as well. That's why I'm allowed to do all of this stuff. Oh, did I cross out the C? I should have done that too, shouldn't I? Because if you can multiply in any order, then we can cross all of these things. It doesn't matter whether they're next to each other. 3 times 5 is 15, and 5 times 3 is 15. It's irrelevant. Now, do you remember how to divide fractions? We tend not to divide fractions because that doesn't make a lot of sense, because this is saying 6b cubed divided by 5 divided by 2b to the power of 4 divided by 6. That's a bit crazy. So remember, we flip and multiply instead. So we're going to turn this into a multiplication and flip the second fraction. So I'm going to say 6b cubed over 5 times 6 over 2b to the power of 4. And again, I can cross out things now or later, it doesn't matter. So I have 36b cubed over 10b to the power of 4. So then if I simplify these, I can divide them both by 2. So this becomes 18, and the bottom becomes 5. That's the weirdest 5. And then 3 minus 4 is -1, so b should be on the bottom. All right, so that's about when we've only got multiplication and division. What if, like over here, I'm actually adding different fractions? Now, hopefully we remember this easy stuff. If the denominators match, then you just add straight away. So I've got p squared, q squared over 5. I don't have to do anything. I can't cancel. There's nothing in common. Once the denominators match, you can just add the tops. But for this one, the denominators don't match. So what I'm going to do is multiply this fraction by 2 so that the denominators will match. So I should have 2 over 2w, see how this is an equivalent fraction, minus 3 over 2w. Now that the denominators match, I can just do 2 minus 3, which is -1. And it doesn't really matter where you put the negative, right? Because the whole fraction's negative. If the numerator's negative, the whole thing's negative. It's only when both parts are negative they cancel out and become positive again. All right, what about something like this? Same thing. I'm just going to make sure this one ends up matching this one, so I'm going to double the whole thing. So I'm going to double both top and bottom, so I get 6r over 14s plus 2r over 14s. Put them together, I get 8r over 14s, but I can simplify this number, right? I can divide them both by 2, so I have 4r over 7s. So keep going until you can't simplify anymore, whether it's with letters or with numbers. I think those were all the examples I had. Yep. Okay, great. So hopefully that was mostly a revision of your indices laws and simpler fractions. We're just putting letters in with them this time too. Okay, get in touch if you need some help. Good luck.